Assalamualaikum, my name is Haris Mukhlis bin Muhammad Idris. Today, me and my group will be presenting about the topic space weather. The group members are Haris Mukhlis bin Muhammad Idris, Muhammad Azra Ashman bin Rizalman, and Muhammad Aiman Hakim Muhammad Aidil. This is the structure of the Sun. It is divided into 3 layers: corona, chromosphere, and photosphere. 9.1. The activities of the Sun that affect the Earth.
Right, firstly we're gonna talk about granules. Granules are the brighter regions which appear grainy on the photosphere. Granules form the upper regions of the convection zone where the plasma has higher temperatures than its surroundings. This temperature of granules is about 5,800 Celsius. Average diameter of granule is about 1,000 km. Each granule lasts only about 20 minutes. After releasing light energy to outer space, the plasma becomes cooler and moves downwards away from the upper regions of the convection zone. This explains this disappearance of the granule. Sunspot. Sunspots are the dark regions on the photosphere. Sunspots normally exist in pairs of groups. Sunspots form the upper region of the convection zone where the plasma has lower temperature than its surroundings. The temperature of the sunspot is lower than the temperature of the photosphere at about 3,500 Celsius. The temperature of the photosphere is typically 5,500 Celsius. Due to its lower temperatures, the sunspots appear to be black on the surface of the sun. Diameter of a sunspot is between 1,000 km to 50,000 km. Sunspots can last for more than a week. Solar cycle. Sunspot activity appear and disappear repeatedly in an 11-year cycle known as the solar cycle. The diagram shows the location of sunspots, which are the place of eruption of gases and plasma on the photosphere since 1875.
Prominent solar flare and coronal mass ejections are phenomena in which plasma are thrown out from the sun to outer space. Prominent is a large coil or arch column made up of glowing gases over sunspots. Prominence can reach heights of hundreds of thousands of kilometers. Prominence may last for a few days to several months. Glowing gas can be thrown out by powerful prominence into outer space at speeds ranging from 600 km per second to more than 1,000 km per second. Solar flare. Solar flare is a column made up of numerous charged gaseous particles from the sun shooting outward in violent and spectacular gas explosion near sunspots. Solar flare increase to their maximum brightness in a few seconds and then fade over several hours. Light from solar flare travelling at light speed take 8 minutes to reach the Earth. Charged gaseous particles shooting outward by solar flares into outer space at high speeds take several tens of minutes to reach the Earth. The charged gaseous particles interact with the atoms and molecules in Earth's atmosphere to produce aurora. Coronal mass ejection. Coronal mass ejection appears as a large cloud made up of magnetic gaseous particles shooting outward from the sun and occurs together with strong and large solar flares. Coronal mass ejection shoots magnetic gaseous particles outward into outer space and appears like an expanding cloud. Magnetic gaseous particles shooting outward into outer space at high speeds take 3 days to reach the Earth. The magnetic gaseous particles interact with the atoms and molecules in the Earth's atmosphere to produce aurora. Solar wind. Solar wind is made up of charged particles in plasma such as electrons, protons and alpha particles which shoot outwards from the sun into outer space and move together at high speeds. Solar wind, which contains magnetic gaseous particles, carries the interplanetary magnetic field together with it. Solar wind travels at supersonic speeds between 250 km per second to 750 km per second. The speed, temperature and density of solar wind normally change in its path.
The Earth magnetosphere. Space around the Earth that is controlled by the Earth magnetic field. The function is to protect the Earth from the solar wind, stems from the Earth's magnetic field, generated from an electric current generated from the movement of a convective current of molten iron in the Earth's outer core. The shape is produced by the Earth's magnetic field that protects the Earth from solar angina from the Sun. Without the magnetosphere, the solar wind would destroy the Earth's atmosphere. The effect of no Earth atmosphere is that air will disappear from the Earth's surface, water will not exist in liquid form, and harmful ultraviolet radiation will reach directly to the Earth's surface because there is no ozone layer. Space weather. Space weather is defined as the phenomena that occur on the surface of the Sun, such as sunspots, prominence, solar flares, and coronal mass ejection. In outer space, such as solar wind, solar radiation storms, and geomagnetic storms. Seasons in space weather are related to the solar cycle, which is the maximum and minimum sunspot activities occurring in a 11-year cycle. From the surface of the Earth, space weather refers to the surrounding conditions from the thermosphere layer to outer space throughout the exosphere layer and magnetosphere. In solar radiation storms, high-speed protons shoots outwards from the Sun. These high-speed protons collide with atoms and molecules in the ionosphere to produce free electrons that absorb radio waves and disrupt telecommunications. On Earth, these high-speed protons damage human body cells and electronic circuits. In geomagnetic storms, the energy in magnetic gaseous particles in solar winds are converted into heat, which is then transferred to gaseous particles in the ionosphere. These heat changes the densities of the gases and the magnetic field in the ionosphere. Changes in the densities of gases disrupt radio signals and navigation systems such as GPS. Changes in the magnetic field produce geomagnetic induced currents in power electric lines and pipelines. Interpretation of data on space weather. A satellite network to study outer space weather, also known as the Evolving Hylophysics System Observatory, was set up in outer space to collect space weather data. Space weather data is used to analyze to predict when a coronal mass ejection will happen in the Sun and its disruption to telecommunications, navigation system, and electric power lines on Earth. And it is also used to determine the reasons for the occurrence of coronal mass ejections and solar flares on the surface of the Sun. Fun fact: did you know that the collision of the solar wind with the Earth's magnetic field is known as bow shock because it is arc-shaped? And the changes in weather explains events such as ice age and great oxidation event. Last but not least, tachyline is a transition region between the convection zone and the radiation zone. Thank you.